We are going to be solving linear systems by substitution. And let's look at the rules. Number 1, solve either of the equations for one variable in terms of the other. If one of the equations is already in this form, you can skip this step. Number 2, substitute the expression found in step 1 into the other equation. This will result in an equation in one variable. Step number 3, solve the equation containing one variable. Step number 4, back substitute the value found in step 3 into one of the original equations. Simplify and find the value of the remaining variable. And step number 5, check the proposed solution in both of the system's given equations. So we're going to have two linear equations. The method that we're going to use to solve these two equations is substitution. When you're solving a system of equations, you are finding the point where the two lines touch. That is your solution, where the two lines touch. So let's begin looking at an example involving substitution. So let's look at this example, solve a system of equations by substitution. So our first step is to solve one of the equations for a specific variable. My suggestion is to look at all the variable terms. Do any of these have a coefficient of 1? X does. That's the variable that I would solve for. That's the easiest way. A lot of times that keeps you from involving a lot of fractions. So I'm going to take this second equation and I'm going to solve it for x. So I have x minus 2y equals to negative 3. So let's add 2y to both sides. The 2y's cancel. I end up with x equals 2y minus 3. So this is what x equals to in the second equation. Now, our steps earlier told us to take what this variable is equal to and substitute it into x in the other equation. So I'm going to take the other equation, and everywhere I have an x, I'm going to plug in what x is equal to, and that is 2y minus 3. Now continue on with this equation, minus 4y equals to 9. So I solved for x in this equation, found x to be 2y minus 3. I plugged in what x is into the other equation. Now I have the same variable, only y, so I can solve for y. So go in and distribute. 5 times 2y is 10y. 5 times negative 3 is negative 15. Minus 4y equals to 9. Combine like terms. 10y minus 4y gives me 6y. Minus 15 equals to 9. Now let's add 15 to both sides. Solving this equation, the 15's cancel. I end up with 6y equals to 24. 9 plus 15 is 24. Divide both sides by 6. Therefore, y equals to 4. You have found the y value of the point where these two lines intersect. Now your answer will always be an ordered pair, an x and a y. Well, our y is 4. To find x, we go back and plug in y being 4 back into either one of the original equations. It doesn't matter which one, plug it into either one of them. I'm going to plug it into the second one. X minus 2 times y is 4. Plugging in, we found y to be 4. Okay, so that gives me negative 2 times 4 is x minus 8 equals to negative 3. Add 8 to both sides. If you add 8 to both sides, x equals to 5. Therefore, you found the y value of your answer. So we found the answer to be 5, 4. Now, what we'll want to do is to check this to make sure that we're correct. We'll take each one of the original equations and plug in x and y and make sure that the left side equals the right side. So I'm going to come back up here and I'm going to kind of draw a box and we're going to check it over here. Checking it in the first one. Again, my answer I found to be 5, 4. So let's check the point. 5, 4. So therefore 5 times x is 5. Minus 4 times y is 4. Does that equal to 9? That's the question. Well, 5 times 5 is 25. Minus 4 times 4 is 16. Does 25 minus 16 equals to 9? Yes, therefore this point, 5, 4, satisfies the first equation. Let's make sure it satisfies the second equation. X is 5. Minus 2 times y is 4. Does that give me negative 3? Does the left side equal the right side? Well, 5, negative 2 times 4 would be 5 minus 8 equals to negative 3. The left side, 5 minus 8 is negative 3, and the right side equals negative 3 also. Therefore, yes, the solution that we found, 5, 4, does satisfy both of the original equations. Therefore, this is your final answer, 5, 4. This is the point where the two lines intersect. We solved this equation by substitution.